Hello, everyone. I'm Norm Marks, VP of Automotive here at NVIDIA. Excited to talk to you today at Microsoft Ignite around transforming transportation with the Metaverse and AI on Microsoft Azure. So to begin with, let's talk about how we see the future of all vehicles being software defined. Now, most of us think of this in the context of autonomous vehicles and the opportunity to continue to improve the AI, flash the vehicles over the air, and have the vehicles get better over time, not worse, as today they depreciate the second you drive them off the parking lot. But it's so much more than just AV now. Everything is software defined, from AI cockpits of the future, and we'll talk a little bit more about that, to building digital twins of the factory, starting with design, then a digital twin as we build the vehicle, digital twins to have immersive experiences as we sell vehicles, and even digital twins of servicing vehicles. So that's what we'll spend the bulk of our time bringing to life now, is digital twins, immersive experiences, and simulation and synthetic data generation for autonomous vehicles. So to start with digital twins and immersive experiences, let me bring to life in a little bit more the tee-up that I just gave in the future of everything being software defined. So in design and engineering collaboration, just a few weeks ago at our GTC keynote, we talked about the new JT connector, which will allow us to bring in Siemens NX and Creo and so many other design files that we can enable virtual design and engineering reviews and collaboration. Simulation, I'll talk in much more detail about, but it spans everything from synthetic data generation to planning and control to testing the end-to-end AV stack in both SIL and hill modes. And we talk about, and we're going to see a terrific example of build, where we can both build a digital twin of the factory itself and pull in that design model that we did the collaboration on up front and see how the vehicle will perform in the factory. Terrific opportunities here for digital twins to take cost out in terms of the build of the factory, but also the production of the vehicle. And then imagine a world where we're sitting in a virtual showroom or from our couch configuring a vehicle and eventually doing so in VR and AR mindsets. What an immersive experience, and even experiencing the AV before I buy the vehicle. And then ultimately service. Imagine if we saw, hot lighted in green, yellow, and red, that the braking is well inside of expectation, it's green. Power steering maybe is highlighted as yellow because the performance out in the field is in threshold, but not what we'd really want it to be. And some other part is highlighted in red. Now, instead of just traditional predictive maintenance for vehicles on the road, I'm visually seeing how is my fleet performing out in the field. So Omniverse is at the center of all of this and enabling so much development of these digital twins and immersive experiences. Today, we have an opportunity to actually see several of these in action. Before I get to the actual examples and a few videos that we have, let me say just a little bit more about a digital twin and a few key components to bring them to life. One is leveraging inside of Omniverse what we call USD, Universal Scene Description, to pull in all the variety of different data sets that you have in your organization and create one extensible single source of truth that we can use for these digital twins. Everyone can still author in their tools of choice, but we bring them all into one place in Omniverse that we can then use that data to create physically accurate replicas. So important that it be physically accurate and have the proper physics. So humans move as humans would move, assembly lines flow as they would, vehicles drive as you would expect. And then with AI cockpits and so many other examples like human ergonomics, it's about being AI enabled, but also enabling AI inside of Omniverse. One example would be if I'm in a configurator, imagine I'm speaking out, make the exterior red, make the interior a certain package, and then a recommender engine running it real time and suggesting something to me while I'm talking. This is an example of AI-enabled digital twins. And then ultimately that everything is totally synchronized. As I said, work in your tool of choice, Omniverse renders just the latest and greatest view, while behind the scenes people are continuing to make changes to the design or the factory itself. So BMW is the first example we'll give. They've done some terrific work building a factory digital twin where they've pulled in data from all types of different assets, the vehicle itself, the factory plan. They've actually pulled in data on humans and human performance. They've trained their robots and have also used synthetic data generation to be able to do so. And created a very comprehensive factory digital twin. This is something they took a digital first approach and have done some outstanding work. We have a video that will actually bring this to life for you. So let's see the BMW factory in action.
BMW has continued building on the momentum of their Factory of the Future initiative we showed you earlier this year. On average, they produce one new vehicle every minute, expanding the initiative to now include digital twin projects at 3 additional factories, which total more than 6 million square meters. Meeting BMW's demands for continuous improvement and innovation requires simulation of complex production scenarios to speed output, increase agility, and optimize efficiency everywhere. NVIDIA Omniverse introduces new simulation capabilities everywhere BMW needs to make critical decisions and introduce automation. BMW and their partners have also been connecting new users and tools to expand the Omniverse ecosystem. Spanning every aspect of the BMW Factory of the Future, Omniverse allows BMW to collaborate and simulate from the entire plant level down to comprehensive engineering detail.
Well, digital twin of the factory certainly can have huge impact on the business. It can accelerate time to market. It can take out considerably cost of production, hundreds of millions, if not into the billions. But of course, we need to sell vehicles, and Omniverse and immersive experiences are making a huge leapfrog change in terms of how future vehicle sales will occur. No longer do we need to rely on static 2D models and configurators. First of all, we can create sales and marketing content that is 3D, full videos, and imagine actually being able to have a commercial built in Omniverse where we're seeing the vehicle perform and drive in a scene that's all virtual. We love the idea of customer service AI-driven assistance. And while here we see depicted a retail kiosk, imagine that AI assistant sitting in the head unit of the vehicle, talking to you on the drive, asking you what you might want for dinner that night, providing recommendations to you that make sense either for driving or eventually when we have full level 5 driving and we're all passengers, having intelligent customer interactions with you while you're in the vehicle. I believe that this will go a long way towards loyalty of the future as well. And then I already hinted at this earlier, configurators and virtual showrooms. Today we have customers that have a showroom where we can put on a VR and AR experience. An assistant can prompt seeing how the vehicle would drive in the highway. How would a vehicle drive in an urban setting? But as I said, now with the advent of injecting even more AI into the immersive experience, we can just speak conversantly and have an AR experience where we say, now show it to me driving towards the beach while the sun is setting. And we can really experience the vehicle driving, as I said, well before we would ever do a literal test drive and certainly before we would select the vehicle. So really exciting opportunities that we're seeing here. We're going to have an example of that as well.
NVIDIA Omniverse Cloud is a suite of software and infrastructure as a service for designing, publishing, and experiencing metaverse applications from anywhere on any device. Let's see how Rimac, technology pioneer of AI-enabled hypercars and advanced electric solutions, can enable collaborative workflows for their 3D teams and deliver advanced 3D experiences to their audiences with Omniverse Cloud. The 3D models of cars such as Rimacs are designed by large teams of uniquely skilled individuals each using their own specialized tools. Here, designers connect to Omniverse Nucleus Cloud, their shared database engine. With USD workflows, they can aggregate full CAD fidelity datasets from their favorite tools, including Autodesk Alias, Houdini, Adobe Substance 3D Painter, and Omniverse Create. Each designer either works on their individual RTX computers or streams Omniverse apps from OVX servers in the cloud. Once complete, Rimac integrates the ground truth USD model into an advanced real-time 3D configurator and publishes it to the NVIDIA Graphics Delivery Network, a planetary scale network of distributed data centers that stream high-performance, low-latency 3D experiences to edge devices. Today's configurators are limited by pre-rendered options that can only be shown in a single scene. With the end-to-end USD pipeline, Rimac fans and consumers are configuring the actual engineering dataset, not a simplified model, in full fidelity with physically accurate materials and real-time RTX ray tracing. This unlocks all possible design permutations without Rimac having to manually render every option as a layer. Omniverse Cloud connects 3D artists, designers, and metaverse viewers at every edge of the planet and delivers the possibility to build and operate advanced 3D internet applications on any device.
So the Rimac configurator is just so exciting. You saw from up front being able to see the design collaboration that was done to bring the vehicle to life, but then also having that configurator experience with the vehicle, having it be exactly what you want when you purchase it. And then ultimately, that configurator can lead to a virtual reality and an AR experience. Now, what you didn't see in the Rimac video, what I want you to imagine now, looking at the left-hand side of the screen, imagine if we were actually seeing bounding boxes picking up objects, maybe a deer crossing the road, and we could actually see that happening in the experience. We're seeing the lane lines depicted. So we're seeing the AV working. This can give us so much confidence in the vehicle itself, again, even before we do a literal test drive. By the way, the same thing would be true once you own the vehicle, having that AR heads-up display while you're driving. I've already talked about the configuration at the time of sale and the immersive test drive, but imagine at the point of service, having an AR exploration. Here you're seeing someone depicted in the service bay that's getting a sense of what might be going on with their brakes. But imagine that you've done this the other way and you're FaceTiming the dealership because you've dropped the vehicle off the night before and gone home. But now when the dealer the next day is looking at your vehicle, they could be having an immersive experience with you saying, see what we're seeing with the brakes and the need for repair. Really game changing. Whereas today, this is a phone call and you just take it at their word for what you're not seeing when you're not there. So terrific opportunities, connected customer and showroom. And we think showroom, we think sales, but again, this will extend all the way down to service as well. Now, we mentioned at the beginning that we were talking about transforming transportation. Up until now, everything that I've been talking about is transformational activity in automotive, which is near and dear to my heart. But we've also got a terrific success story with Deutsche Bahn. Railways is, hundreds of billions of dollar industry. And in Germany, Deutsche Bahn really wanted to be able to apply a digital twin of its rail network to improve the efficiency and the capacity, but without having to build new tracks. So with 5,700 stations and 33,000 kilometers of railways, you can imagine how complex a task this is. And so many data assets having to come in, from HD maps to the design data sets to simulation tools. You heard me talk about the JT connector earlier in the talk. And they did build that single source of truth in USD. Ultimately, the work that they've done, being able to look at both physical and digital world, from camera data to the LiDAR to CFD simulations, is to be able to identify areas where they can make improvements and ultimately ensure that they can get passengers and goods to the places they need to be on time, but reduce waste and the carbon footprint as well. So we have a video that will bring this to life for you.
Digitale Deutschland, or DSD, part of German railway network Deutsche Bahn, is designing and building a digital twin of its rail network to maximize transport efficiency and capacity without building new tracks. Realizing a digital twin of 5,700 stations and 33,000 kilometers of railways is a massive undertaking, requiring a custom 3D pipeline connecting DSD's HD map with CAD datasets and simulation tools, including those from Siemens JT ecosystem. In NVIDIA Omniverse, based on Open 3D Framework Universal Scene Description, the teams are able to connect and aggregate critical data sources into a single high-fidelity model. With a single source of truth, DSD can use the digital twin to test and validate the entire network, enabling continuous improvement in the deployment of vehicles and railways, maximizing operational efficiency and speed while reducing costs. Beyond simulation, the digital twin will provide the environment to train the complex AI that manages the fully automated railway system. Running on NVIDIA OVX, the digital twin can be synchronized to the real-world trains and rail networks via 5G-enabled sensors and 5G Edge microcells. If a train's cameras or LiDAR sensors detect a potential hazard, its precise location can be quickly relayed to the rest of the trains in the network, preventing a collision or congestion. If the AI-powered computer vision-enabled cameras at a station notice an issue, an event can be triggered to instantly notify personnel. The intelligent sensors are trained and optimized on a combination of real-world and synthetic data generated by Omniverse Replicator, ensuring the models can perceive, plan, and act when faced with any scenario. With Omniverse AI-enabled digital twins, Deutsche Bahn is working to increase efficiency and capacity of the existing rail networks, reducing waste and carbon footprint, while keeping passengers and goods on time.
So now let's pivot in just a few words to round things up around autonomous vehicles. I won't take us through all the detail here, but it's very computationally intensive, from ground truth data collection to labeling and mapping and developing, 20 or more DNNs for level 2+ driving, all the way up to, we've got customers who are developing upwards of even 50 DNNs all the way as they work towards level 5 robotaxi. But simulation is what I want to spend just a few minutes talking about here, so that we simulate and ensure safe self-driving vehicles before we deploy them on the road to have automated driving, testing routines like NCAP, parking, and then ultimately those AI cockpits that you've heard me already talk about. Synthetic data is super important for us because we can use it to address real-world challenges. One of the things that's really difficult about the AV stacks is we need diverse data. And so with synthetic data, we have full control over this. Earlier, I mentioned on the video that we'll see to follow that, it's difficult to send a data collection car out to get certain scenes. Of course, rare and dangerous corner cases, like I hope you wouldn't send a vehicle out to catch Norm on a bicycle cutting in front of a vehicle traveling 70 miles an hour on the highway. That's just one example of the corner cases, but there's so many others. So we want full control over that. When we're creating data assets with SDG, we can do it so much faster than relying on data collection cars. And to the same end, without relying on data collection cars, so much lower of a cost to be able to collect and label the data. If you think about it, when you're creating synthetic data assets, you're actually describing the scene that you're looking for. Show me a vehicle on a highway, and I want to see crashed or emergency vehicles on the highway. And so in effect, what you're doing is you're actually labeling the scene in advance when you're constructing the scene. There's no human errors involved here because it's fully automated and pixel level accuracy of labeling. And it can also help us deal with situations in some parts of the world where we may have data restrictions. So now let's talk a bit about DriveSim itself. It's a broader platform designed to do more than just SDG that we'll talk more about, but also planning and control cell, end-to-end AV simulation in sill and hill modes, and virtual vehicles. In our GTC keynote, we talked about neural scene reconstruction, taking previously recorded drives and turning them into synthetic data scenes and simulation scenarios. So we can create both synthetic data assets and simulate the world. And we can also do virtual vehicle simulation of in-cabin, looking at the cockpit, but also gaming, for example. So really exciting things that are coming down the road with GTC. And again, I'd encourage you to watch the GTC keynote, one of the resources that we have available to you after the talk. So now let's take a look at Drive Replicator in action. So here, imagine trying to tell a data collection car, go out, find 5 or 6 ambulances and police vehicles on the road. It's not just camera data that we're generating. We're generating LiDAR and radar at the same time. We're also see segmentation, as you see depicted on the screen. Again, look at this really complex scene with the lights and the at night. We can also generate data on occluded pedestrians. Domain randomization speeds us up. Here we're seeing a variety of pedestrians, cones. We'll see a variety of shopping carts. So imagine we just described one scene going into this plaza, but then we randomly produce a number of assets to be able to make that run faster for us. And we can also do multi-sensor simulation. So 4 places that we've already applied this. We've improved our path networks, our AI for path detection by as much as 10%. We cut months out by emulating sensors before we had them. We've improved our ability to spot traffic lights by as much as 3%. And we were struggling with certain signs in Europe, and we injected these data assets synthetically, and we improved those networks by 2%. When we're talking about safe self-driving, these kind of improvements are significant material. And so a few concluding thoughts. First of all, it's all about taking advantage of the opportunity to centralize your data assets and yet keep that synchronization that I talked about earlier. You've heard me talk about a broad set of use cases. My challenge to all of you is figure out for you, where's the most value to your business today? What's your phase 1 through phase 5 set of projects that you can do to bring digital twins to life? Knowing that you can apply physically accurate simulations and leverage synthetic data up front to be able to get more work done. Now, we're here at Microsoft Ignite. So the final point, of course, is you can start and develop potentially on workstations, but scale in the cloud. So we've built NVIDIA Omniverse Cloud. And of course, we encourage you to consume it at Azure and get started now. There's no time to waste.